Hello, I'm Jennifer Hartman with Rogue Detection Teams. Thank you very much for allowing me to speak with the working group today. This short talk focuses on lessons learned from working with detection dogs for Sierra Nevada red fox surveys. I want to share operational and design considerations that may be useful to land managers and researchers who are less familiar with this methodology. First, a real quick intro into the method for anyone who might be new. A detection team is a unit, a high-drive dog taught to detect odors in the wild, partnered with a field scientist, who we call bounders. Bounders spend many years developing a deep understanding of dog communication and how to partner with dogs for non-invasive wildlife detection. Some of the most frequently asked questions we receive are centered around the dogs. Everyone wants to know what makes a detection dog a detection dog. Should my pet dog be a detection dog? At the core of it, no. We adopt dogs who need a job. This method relies on recruiting and adopting dogs with extreme drive. These dogs tend to be out of options in shelters due to this drive. Their intensity and need for a job makes them ideal working dogs. Detecting odors in the wild becomes an outlet for their intense energy. Detection teams are non-invasive, and surveys are conducted with an emphasis on minimizing disturbance to the ecosystems we work in. The goal is to move through the landscape efficiently, focus effort where it's most likely to be informative, and collect biological samples without altering animal behavior or habitat. In systems with very low encounter rates, like with Sierra Nevada red fox, and in large, remote, or rugged landscapes, detection teams have been shown to add value for data collection. In these settings, gathering sufficient information using any single survey method can be challenging. As with every method, access limitations and funding constraints shape what is possible in the field. When time on the ground is limited or areas are difficult to reach, detection teams can provide an additional way to locate biological material that complements other survey approaches. This map shows where detection team surveys for Sierra Nevada red fox have taken place over time. Detection team experience with this species spans multiple years and regions, including work in Oregon and in California in Yosemite National Park, the Sonora Pass region, and more recently with the California Department of Fish and Wildlife biologists throughout the Sierra Nevada red fox range. Experience plays a significant role in how detection dog teams function in the field. For red fox work specifically, experience has taught us how to safely dispatch our dogs for intense surveys at elevation and for multi-day treks, ensuring dogs maintain health and fitness for the duration of the rigorous survey conditions. Regional ecological knowledge also matters. Familiarity with seasonal patterns and animal movement helps teams interpret what they're seeing on the ground and decide how to direct effort. Ongoing collaboration with researchers and managers allows that experience to be shared and incorporated into planning, improving how surveys are carried out over time. In low-density systems, survey design matters as much as effort. We've learned that simply covering more ground does not always increase the chance of detecting samples. Focused design means targeting habitat that is known or suspected to be used by the species, and aligning surveys with the time of year when animals are more likely to leave detectable sign. Rather than exploratory surveys, this focus helps reduce unnecessary mileage and dog fatigue while keeping effort directed towards areas that are more informative. For example, in Lassen Volcanic National Park, we focused on summer range rather than winter habitat, which helped concentrate effort where detection probability was higher. Especially when funding is limited, historical data supports informed decisions about where and how detection dog teams are deployed. Information from previous detections, camera deployments, caller data, or earlier surveys build a clear picture of how a species has used the landscape, which guides bounders in directing their searches. Supporting data also helps with interpretation. When teams know what has been documented in an area previously, it becomes easier to distinguish between a true absence and a non-detection related to timing, conditions, or limited sampling. Used this way, historical data provides detection teams with important context before ever entering the field. Access and logistics play a major role in how surveys unfold in the field. Discussions about boundaries, permits, and where teams can camp all shape what is possible day to day. Advanced coordination helps avoid surprises once teams are deployed. Agency support is an important part of this process. Communication about access, timing, and expectations allow detection dog teams to focus effort on survey objectives rather than problem-solving logistics on the ground. With pre-planning, dog teams are better able to conserve energy and direct their effort towards areas where surveys are intended to be informative. Starting surveys in known or suspected hotspots is important for maintaining dog motivation and validating scent recognition. With rare species like red fox, detections may be infrequent, so layering additional species does not distract dogs and can actually support motivation. Secondary data can also inform broader ecological questions, such as predator interactions, prey-based changes, or competition with other species, such as coyotes. Within a single species, odor can vary in meaningful ways. Differences related to sex, diet, season, and region all influence the scent profile associated with biological material. Exposure to that variation helps detection dog teams recognize the range of odor they may encounter in the field, rather than relying on a narrow or uniform scent picture. Here, one of our new detection dogs, Echo, is learning the odor of red fox from a training sample collected in the wild and genetically confirmed at the MECU lab. This becomes particularly important in large or environmentally diverse landscapes, where animals may be feeding on different prey or using different habitats across the year. Accounting for odor diversity helps teams maintain consistent discrimination and reduces the risk of overlooking samples that differ from what was encountered earlier in the survey. In systems where target species occur at very low densities, surveys can involve long periods without detections. In these situations, incorporating detection of additional species can serve a practical role. Locating sign from other species helps maintain consistent search behavior and engagement over long survey days, particularly in large landscapes where effort is spread over many miles. Multi-species detection can also provide broader ecological context, information about which species are present, where sign is concentrated, and how animals are using the landscape can help inform interpretation of target species results. This approach does not replace focus surveys for specific species, but it can add useful context and support sustained, consistent survey effort in low-density systems. Sierra Nevada red fox surveys place real physical demands on both dogs and bounders. Working at elevation increases fatigue, and prolonged sun exposure can affect stamina and recovery over multi-day surveys. Managing fatigue is an ongoing part of the work. Teams need to pace effort, build in rest, and adjust daily plans based on how conditions and energy levels change over time. Remote access adds additional constraints. Long approaches, limited resupply options, and weather variability all influence how much time can be spent searching and how flexible daily routes can be. These realities shape survey outcomes and timelines, and they need to be accounted for during planning rather than addressed only once teams are already in the field. Detection dog teams are a limited resource. Building and sustaining teams with the experience needed for remote, low-density survey work takes time to develop. This experience expands over years, not single projects. When detection dog teams are brought into planning, supported with existing data, and deployed with a shared understanding of survey goals and constraints, the information collected can contribute meaningfully at a range-wide scale. Framed this way, detection dog teams function as part of a collaborative process, one that depends on coordination between researchers, managers, and field teams to build a cleaner picture over time. Thank you again for the opportunity to share a few insights from detection team surveys for Sierra Nevada red fox. The work we conduct alongside our detection dogs is only one piece of the puzzle, and we are grateful for the collaboration of many individuals, agencies, partnerships, and collective knowledge of Sierra Nevada red fox that has guided our survey efforts so far. As long as my connection supports it, I am happy to answer any questions at this time.